Let's hope it works. Okay, cool. Hello everybody. I think we figured out the stream settings and now streaming the channel. I don't have the camera on, but let's see if we could do that one. Okay. Hello, here's me. And let me make it smaller. Okay, great. So hello everybody, sorry for the delay. I hope you get in the audio, and if you do, please post something to the chat. That's the same way we used to test it previously, and I hope that it works now. My camera is off center, so you can see me looking off screen. That's specifically for the reason that that's how it is. Actually, yeah, let's leave it this way. Okay, sounds like we get in the audio. Hello everybody, my name is Lex and I've been in software engineering for about 20 years and I migrated a couple of companies to Git, which is the topic of the lesson today, or the presentation, not really the lesson. Before we begin, I want to say one important thing is that I know that I speak fast, especially when I'm talking about anything I'm really interested in, and Git is one of those things. So whenever I go too fast, plus I have an accent, please don't hesitate. Post something to the comments on the stream. Hopefully I'll notice and I'll adjust. Anyway, let's begin our current presentation. It's about Git, and I'm going to show you a presentation. The slides are not done by me, and I'll share the link later on in some Twitch and some Slack organization. But the point is that it talks about Git itself, not about GitHub. And let's jump straight to it, because Git is a version control system. And the most important bit is to understand what it's used for, like what kind of a problem it solves. And if you use computer for more than like a week, you've probably been in the situation when you already create a like file, make some changes to it, and then there is a revision of it, and you create like edit it or .new or .old, and you have like eventually folders with like revision 1 or edited or modified, and then you have like 5 different versions of the same file, and eventually it's getting hard to figure out which one is the latest. So this is a file-based version control, essentially. The idea is to keep track of what is the most recent version of a file and what were the changes made to it, with the idea that you can go back to any version that's been in use previously. It is extremely important for software development because any program is a collection of files. And it's important for the team to track of who made which changes and how they were applied, in which order, at what time, and all of that stuff. Okay. Oh, cool. Yeah, thanks for the for sending the link for the slides. It's exactly the slides I'm showing. Okay. So the best way to think about any version control system, this is not specific to the Git, is that it's a kind of like a time machine. It allows you to see the same file or set of files as they were seen in time. And sometimes it's extremely powerful. I sometimes go and look at some open source project and see where it all started. And sometimes people do that for fun. Sometimes it's an important milestone. And most of the time, though, people do that because they want to figure out when did we break that bit. So there is a comic on this slide deck that shows that, well, version control does not necessarily has to be Git. And it's totally fine. Like, for example, in this case, person writes entire set of documents that he's working on a flash drive and just puts them in the cap. Cool, that works. Though it might not be as scalable and kind of expensive eventually. So it could be used for anything. Important bit that I actually used Git for the very first time right in my thesis in the university, and that was everything I've done, all the charts, all of the documents, all of the scripts that were used to run to process the results of the experiments. So anything was under the version control system, and it was extremely useful because then when I was on the time crunch and I had to come back and find the modifications, it was so invaluable for me to be able to go back. And one of the most often used operations that I just broke something, I made some local changes, and the program no longer works, and I want to start from scratch, like go back to the good state. I know that it worked before. So version control system and Git as well have this operation that says like, well, discard of whatever I changed since the last time it was good. So whenever now I get the program in a working state or anything like a good state of the slide deck, I commit that to Git locally anyways. Just so I have that save point in Time Machine, and I can come back to the exact same good state again. And another important thing is sometimes Git is presented straight up as a solution for the teams, for the companies, for huge open source projects collaborating over the internet. I want to stress that it's actually not limited to those. You could use it for your own files on your own machine without any internet involved at all, and it's still going to bring you value. And I do have one repository with just like that, when it's not on GitHub, not shared with anybody, just because it keeps track of the changes that I made to a certain set of files. It's extremely useful. So this is an introduction to the version control system. And before I go further into the Git itself, I want to quickly say that if you have any questions, post them to the stream chat because I can see it. Some use cases. I already covered them, but this is to talk about them in more details. First one is that you have multiple people working on the same file. This is exactly a use case you will see during the HighTechU program, because you're members of the team and you're working on the same product. This is by far the most common use case, however, not the only one. The other one is that you can change, keep track of the changes that you've made to the system. You could put the entire OS into the Git repository if you want to. I'm not recommend that part. But anyway, so just to see what changes ever, like which files and when. And another thing is that you could use it as a way to replicate some sort of config changes. So it's exactly the same on multiple servers, which is also quite common. And it's common enough that even some operating systems use Git to deliver updates. Essentially, anything that the operating system is in Git, and all of the tooling that we wrote just use Git behind the scenes. But we're going to focus on this one for today. But start with even simpler use case is the workflow. Working with the Git, this is not necessarily even with remote repository. Just with the local one, you will be most of the time repeating the same set of steps every time you make any changes to the project. Either your own file, like writing a story, doesn't have to even to be code, or working on the team project in HighTechU. First, you somehow open the repository. Maybe you clone it from the remote GitHub. Maybe just means go to the folder when it's local on your machine. Then, ideally, you create a branch for your work. Then you do some work, which means change files. We'll talk about branches a little bit later. But this is a useful way of Git allows us to have more than one copy of the same file at the same time, which is essentially how the different people could have their own work separated and have their own view, but then eventually it all comes together. That's how the tree and the branch look like. We'll talk about how it looks in detail a little bit later again. Okay, so after you've done some work and you made some changes, you check in those work, which is a commit in the terms of Git. You add those files, which is a set of changes. You wrap it up essentially in the commit, saying like, this is a bit of work that I've done. Usually you don't do anything, but it comes with a description, which is also useful. It's like, oh, I finally figure out that bug, or maybe wrote a new chapter. It's nice to have that description of what exactly was the work you've done. Extremely important for others to see as well. So I want to make sure that after you've done some changes, this is a crucial part of Git specifically, not all the version control system have it, is that you wrap the changes into a box that's called commit, and you kind of like put a message on it, put a label. This is very important. And Git automatically attaches your name to it, saying like, this person did this work at that time. All of that you can change, but anyways, like by default. And then even for yourself, it's already valuable because now you know what you've done and how many hours you spent working on something, for example. And then you could push that branch somewhere for others to see. This is optional, but this is how the team operates. And then the other optional step is merge branches from the. It means that you bring the work that others done doing the same workflow, they pushed their branches and you can merge them, meaning that you'll get the work that they've done on your local copy. You can make sure that it works together with the changes that you've made. You may look at, improve upon it, and push the changes that you made. That's why we have this at the end, that this is going to repeat that flow, which is not too complicated. You do it all over again. As a software engineer, I do it every day. I've done that like, I don't know, 10, 15 times today. Because Git is so lightweight, I don't even notice when I do this commit anymore. Just like, well, yeah, local commit. Each step that we looked in the previous slide is a separate Git command. Git itself is a command line tool which may be a little bit user unfriendly, and lots of slide deck that I looked at getting ready for this presentation were jumping straight into this is the command line, set of arguments, pass it this way. I don't want you to focus on that too much. First of all, because in HighTechU you'll have mentors and stuff to help you with that. Whenever you want to make a step with the Git flow and you don't remember the command, that's fine. There are people that are there to help you to figure out the exact syntax or remind you. There's also Git cheat sheet that makes it easy to remember. So, and also there are visual interfaces for Git, which will have buttons for that. So you don't need to remember that. And if you eventually will, if you use Git for long enough, but you don't have to start from that. I don't have to stress by that, because Git has a lot of commands. Every step that we had in the previous step has one or more commands that are associated with them. You don't have to remember them all. Okay, and then it's really flexible. So once you figure out what commands do, you can actually go and create your own workflows, which will evolve, but you don't have to. So couple of bits information about the Git, which is a set of tools. Important thing is that GUI is available. And it's open source, so it's freely available. You could download from the main thing. Usually, lots of OSs have different ways to distribute it, but it comes pre-installed on the HighTechU environment, so I think you should already have a script that installs it. Anyway, and then final bit that I want to talk more about is the repository. Repository is a storage. It could be local, so whenever you initialize the Git locally, it creates a repository. It's essentially just a special folder. Could also be remote, like GitHub is an organization that manages repositories for lots and lots of teams out there. There is also Bitbucket, there is also GitLab. There could be, but essentially this is something that you could upload your work to. And Git being decentralized version control system, meaning that there could be more than one repository. I'm not going to cover that at all. What I want to have though is that you have some files on your local computer, you're working with them, and the repository also has a copy of all those files. And during normal software engineering work or working on a HighTechU project, there will be multiple times when those files will not be the same. It is important to know that what will get deployed is what repository has. Repository is some sort of a, like, I don't know, the bank vault, when like source of truth resides. You'll have your local repository and there will be a remote one. So you make the changes locally on your files, which are not known to any Git repository first. Then you commit them to the local one, meaning that you package them, wrap with the commit message, and put in a nice little box. with the repository saying like, this is a building block now, building block of my project. And then at one point you ship it over to GitHub. And this is when others were able to see it and able to interact with your work, and also which get deployed. And sometimes you'll hear the vendors or stuff of HighTechU asking you like, did you pull from a repository or did you upload it to a repository? This is important because essentially what's on your local machine, and this is also beauty of the Git, that if my laptop breaks right now, or break down right now, it's not a problem for me as an engineer. I'll just get a new one and get a working environment in like 2 hours tops, because everything I need, everything I work on is always pushed to some repository. So if I want to continue from that point on other computer, it takes like essentially how much time it takes to download a couple of files, and then I'm ready to go again. And now, finally, the time has come to our very first Git command line operation that quite often anything starts with Git init and then the folder name. You could just put the dot to be the current, meaning that it creates a repository if it's not there. It creates a local one. And let's look about at the life cycle of the thing. It's visual representation of the workflow that we've had at the beginning. In the top one, we have the repository, which is on the internet. And then there is a staging area, which is essentially a countertop, and which you package the changes. And before you put it's where you put the ball on the top of it, saying like, this is the files that I want to move. And then the last one is a working directory. It's the list of files that you actually do see in your file system, you work with, you interact with, you can open them in the text editor. And those three areas are separate. And you could always move the files in between them. These are, on the screen, you can see 4 Git commands here. After you made some changes, the first one you run is a git add. For example, here we have git add my file, and you can have a list of files. You can have like any files that you changed. It adds them to the staging area, which means that this is the changes that you do want to push upstream. This is not every version control system has it. It adds a little bit of complication because it's extra step. You do move the files from your local directory to the state of like essentially mark them. This set of changes I like, this set of changes I don't. But it's extremely powerful because sometimes when I'm working with any project, I change a bunch of files around, working certain issue, but only some of those changes are meaningful. Some of them are just me like turning off some log level or changing the log level for the application to put it in the debug state. Or some of them are just, I'm gonna hack that thing here so it does not ask me for the password every single time I log into the application, just logs me straight in. So usually I have changes on my local working directory, which I do not want to share with the world. This step of putting the files to the git add is crucial in me separating of this is the set of changes that are good, I want to push them. And then git commit -m, it's a final ball on that box. It's putting my name on it as an author, it puts the timestamp when I done it as the timestamp when the changes were made, and the message there showing like, I did this is a improvement. And then it goes to the repository. At that point, only to the local one, but that's just fine because it's already there in the history. We can go back to it and I can then go and wreak the havoc to the working directory because I know I'm safe. Like Git holds my back. It knows the good state I was at with my project. I can come back to that anytime, which is that operation. Git checkout -- and name a file would get file from the repository back to the working directory, just as it was. Or from the staging as well. So after adding some file to staging area, but before committing, I could actually make more changes and either add them there or figure out like, oh no, those are bad changes. I don't want them. So I want back to the whatever that was that the git reset will do that. Okay, and essentially files move around through the state, push to repository, commit to the repository, check out from there, and then staging area is something invisible. You could always examine what's in there, but this is also just an area which you would most of the time working on the project in HighTechU will just add anything that you modified and commit them, which is totally fine. One other thing which is sometimes important is that remove files from a repository. After you delete the file from working directory, Git still remembers it, so it's not gone. So there is that rm command when you remove the file and then you commit it. So if you want to delete the file, you commit the deletion of the file. Otherwise, it's exactly the same. You also still have the working directory, stage, and repository. Git status is very important command. So I want you to, if you remember just one operation, that should be it, because this is with Git, with its multiple states in which it could be, sometimes it's dazzling, but it has a good operation called Git status, which shows you exactly what's going on. So first of all, if you do it somewhere which is not a Git repository, it will tell you so. It just say like, this is not a Git repository, and you know that you're in the wrong folder. Or if you have no local changes, everything exactly the same as the files in repository, it will tell you so, saying like you're in a non-good state. Or if you have local changes, it will show you which files has changed. If your staging area is not clean, it will list you the files and change sets that are in the staging area. So this is the state, and also it doesn't change anything. So you can run it as many times as you want. It's a absolutely safe command. And I want you, when I was first starting to use Git, I was actually typing Git status after each Git command that I executed, which is probably overkill, but it's totally fine, because this way you'll see how each of the Git commands changes the status. And some of them don't, like Git status. Doesn't change the status at all, just shows it. Unstage the file is reset. We'll talked about it a little bit as well. So after you added the file and decided, oh no, it's not good, I don't want to commit this change. This is a preset file. I use it all the time. Essentially, my workflow is to stage all the changes that I've done and then handpick, oh, those are hacks, don't put them. This is what I do, like git add all files and git reset the files that I don't want to commit. Otherwise, the same, from the stage into repository, git commit, and then check out to get the back. So this one we should probably skip because, well, yeah, I should mention that one. Most of the time, that operations that you run with Git are perfectly safe, and the Git has the full history of the changes that you made, except for this one. Because this is when you made the changes to the local files and decided that they, like something's totally broke, you don't want to deal with it. And you want to go back to the good known state. So git checkout and changed file will discard the changes to this file. Like discard, it will restore the file as it was in the last good known state. And all the changes that were made to it locally are lost. Like Git at that time does not keep other copy of that one. Most of the time it does. This is the operation when it does not. And then the lab, which we're not going to do. Finally, at one point you'll get to the branching, which is, I think, the very first lab in HighTechU talks about how to do the branches, because essentially this is the way for multiple people to separate their work, and even for one person it's also extremely useful to be able to at one point put aside the work you're doing because somebody called and said like this ticket is more urgent, so we just switch to a different ticket. By having a separate branch per ticket solves it. So branching and merging, I wanted to talk about when we have the illustration. Normally, repository and time flows linearly from beginning to the end, and well, hopefully far from the end. Anyways, this is like what's called master in the Git specific name. That's the main branch is the master branch, and it's usually just linear progression forward. However, at any point of time from master, you could branch off. Usually people branch off from the very best and very latest version of master, but not always, and Git supports it. So you can create a branch for your new nice feature, and you do make some commits to that one. By the way, this is called the graph, and illustrating visualizing the Git history as a graph is extremely common, either left to right or top down, but this is usually how it looks, and each dot here is a commit. Like, remember we talked about the box, which has a bow with a message and the author and timestamp and all the changes inside. So this is the commit. And how we go from one to the other is a relationship between them, which is essentially as them in a straight line of the history of your project. But the history can branch, unlike the real one. So this one, after this commit, we have two set of changes. One that went to the straight to master, and another one went to the nice feature branch. Which means that the changes that we made to master were not affected here. Probably feature was complex enough that we didn't want to deal with making it compatible with whatever the other person was changing on the master. Or maybe just wanted to be in isolation. But the idea is that on the branch we can work independently. And then eventually we can merge, which is important term, merge it back to the master. So in this case, nice feature comes here, and then the new master has all the changes from the master and all the changes from nice feature. Merge is optional operation. So here we have a very nice feature which was not merged. Maybe it's not ready yet, maybe we decide to abandon it. In terms of Git, not a problem. You have a master branch is what will get eventually deployed, and you can have any multitude of branches. They are not expensive in terms of storage, and they can have different code, and it's normal when some of them never find their way to the master. It's still, when you first check out or clone the repository and check out, you usually stay on master, so you can keep working there, but you will use branches, and it's a very powerful feature. These are the command line operations. Do you use the branch? The UI usually have a button saying like switch to the branch or create a branch. So git branch creates a new branch, and you put any name in here, which is expressive because you could give it a name. Ticket, put a name on that. You can put your name in that, like describe what you work on, because it's as far as the Git history concerned, it doesn't keep track of the names of the branches as much. So it does not care what was the name of the branch. So you have full freedom of what to put in there. Usually though it doesn't like spaces, so that's why underscore is in this example. And then you could switch between branches with the checkout operation. Checkout is a very powerful command in Git, so it can do almost anything. Unfortunately, we just get confused. So you will check out master, for example, or nice feature, and means like it changes the local files that you have in your working directory to correspond to what's on that branch. And you could, it's a very fast operation. So you can quickly switch between the master, your branch, somebody else's branch, and make sure and just open an editor to see what the files are, or run the application, or read the text, whatever it is. Well, let's leave the shortcut out because they don't need that. And then on the merging is that we check out the target branch, essentially where we wanted to merge it to, and then we tell Git to merge what is the source branch. The order is important because you see the arrow here is going from the nice feature to the master, not the other way around, which is also possible. Sometimes you just want to bring the changes from master to your feature branch. Totally legit operation. But usually, well, in this case, we're done with the feature. We want to go to be part of our application. We want to bring to the master. Then we check out the branch that we are on, and usually that I also run git status there to make sure that I don't have any local changes on top of the master. So it's in a good, known, clean master state. And the reason is that maybe somebody changed, or me myself changed the very same file in a nice feature branch, and Git will help me to resolve those. It's just easier when you're in a clean state. So after the git checkout master, I usually have git status in between those two commands, just to make sure, okay, I'm good, I'm on master. Because for example, sometimes Git after that command would tell you, oh, I cannot switch there. This is not the clean checkout. You have some local changes that will be lost if you just do that. I have not talked about that at all yet, but it's crucial that you don't only run those operations, you look at what gets printed back, because like git status tells you everything about the status of the repository, other commands, they usually tell you when something went wrong. Most of those operations would print out like a couple of lines, and that's it. But if something's wrong, they put more. So if after running the git checkout master, you get more than one line of output, it means that something is wrong, and you should read what the message says. Maybe you're in a different state and the operation didn't succeed. And don't worry, it has sometimes hints saying like, oh, perhaps you meant that, or things like that. But you also have the HighTechU mentors and staff members to help you figure out what exactly Git is unhappy with. And after we did the Git checkout master and make sure you're in a clean state, we merged the nice feature into that branch. After that, master has all the changes from the nice feature, all is fine, keeping the history, which is important. So let's say on that branch, we have like 5 different people who helped and contributed. They each produced one of those red dots. So we have 5 commits, 5 boxes with a bow and a label saying like, this is a person. So that merge keeps that history all intact. So it will keep the record of who merged the branch, but otherwise each line in the source code, for example, will be annotated with who originally produced it. Also important. So this is very important for the attribution, that like who is the author of the code is never get lost with Git. Almost never get lost with Git, because yeah. Anyway, I should not talk in absolutes, because Git is very powerful. You can do very weird things with it, and you can change who is the author of anything. But normally, during the operation you see on the Git cheat sheet, you won't be able to. Okay, so the master branch is special. It's master is not a special name in the sense that if your team does not like that name and want to call that branch like main or anything like that, you could do that. It's by convention. So if your team decides that master is not the right name for the main branch, feel free to do that. Git is flexible enough to support that. And then you could merge changes from any branch to any branch. That's how it supports that highly distributed work environment that many software companies are fond of. And the old version control system had the person in authority, like there would be an engineer in charge of certain folder or subfolder or project, and like that person would be the holder of the key to all the code. So that is not what Git does. It's highly distributed, and it's not unheard of when the master branch gets abandoned, saying like, well, we did something wrong, and just like and deleted and recreated. Just fine, because it's just like any other branch. It's not that special, just by convention is the main one. We get into the end, so I want to talk about the conflicts just a bit. So one of the big benefits of using version control system is when you have the changes by two people in the same place, which is just a conflict. During the merge, Git will tell you that the two people has changed the very same line or significantly changed the very same file. And when Git can resolve it, for example, they change the very same file, but maybe like one in the beginning, one in the end, then Git will not have a problem with that. It will resolve it automatically. It will just like, when you merge, it will add one line in the beginning and one line in the end, and you will have the combined set of changes. However, if it's exactly the same line, Git will not know which set of changes to take, so it will tell you. And this is usually a scary moment, because you do the merge, you expect everything to go fine, but you have some of the output on the command line, and you have some of the thread saying like, you have conflicts. And I think it even says something like when it prompts you to pick either yours or theirs version of the change set, which is not necessarily what you'll end up doing. You might modify it at the thing, but essentially you just resolve it. And I wish we had an example of the conflict in here, but we don't. So I'll just tell you that Git has tools to resolve the conflicts, and they are less scary with Git than with other source control systems. And what's interesting about the conflict resolution in Git is that it's not special from your workflow. After the merge has a conflict, Git places you in the special status. By the way, Git status will tell you also, this is the files in conflict. So after I get in the conflict and I get the huge message, I still type Git status every single time just to see like, okay, give me the list of files that are conflicted, even though they're just in the output of the previous command as well. And after that, you've done, it's the same workflow. You make some changes to resolve the conflicts, you git add to put them in the staging area, and then you git commit to say like, that merge can commit and go forward, and I resolve those conflicts. We're not doing the lab, and then we're going to skip the GitHub thing as well, because I think that will be a topic of different presentation. Right. So let's see what else do we have. Oh, the GUI clients, right. So when you work with Git and searching for answers online, you'll most of the time will see instructions talking about the command line operations like we had in here. It does not work for everybody. And I've seen lots of very smart engineers who would use GUI client, which is perfectly fine. In fact, I think it's actually getting more common for the people to use the GUI clients nowadays because it's getting integrated into the VS Code or IntelliJ IDEA or other integrated development environment. And people work through them, not necessarily through command line. So that's why I told you that it's not crucial to remember all the Git commands or the Git cheat sheet, because first of all, there's usually a person next to you who you could ask and or online reachable, and like who you could ask and like what was that command to do the merge or set of commands or revert the branch. All of that is very easily searchable. Don't need to remember. And second, there is nothing wrong with using the GUI clients, and there are like multitude of them. For example, I remember I mentioned that it's common to visualize the Git history as a graph of changes. I personally prefer to switch to the GUI client whenever I need to deal with the history. It's just usually like when you need to figure out what was the change set, like who changed this file, or like what, like why is the change is fixed. So nothing wrong with that one, and I don't want you to feel that there is a. Oh, actually, I haven't said that. There is no right or wrong way of using Git. Even the Git book itself, the Git site has the Git book as the main one. Even that one lists several possible workflows. So your local workflow is always stays the same. Remember, then you have like make the changes, git add, git commit, stays the same. However, when it comes to the branches, what get merged where is going to be different, and there are good reasons to use all of the different workflows. For that one, you usually have as the beginning, we have a team lead to tell you like in our company we do it this way, or you have in HighTechU you'll have a flow presented to you with the GitHub and the pull request and everything. A certain way of branches are created and merges. Anyway, with the GUI clients, you're not constrained, so you still have access to all of those branching strategies, and some of them are even comes pre-built. When you install the GUI tools, it asks you like what kind of Git workflow or Git flow you like, and you choose, and it just changes the UI a little bit. Most of them don't do that, but they all support all the kinds of branching strategies. I don't want to demo the UI for you though. Right, so the Git book, I mentioned that, is this one, which is, it's a very long but well written. It's available in different languages. I would recommend you to get to it not right away, even though it's right there from the very same site we downloaded from. However, I would invite you to try and play with Git first. Like for example, HighTechU is a perfect setup for that one, because then it will make the reading of the book way better. First of all, it's all kind of centered on the command line interface. So if command line interface is not what you're using with, then it's going to be harder to read. But if you understand, you already done a couple of commits yourself, you got a hand of what's the staging area for, what the repository is, then it will be way easier to do it, to read the book, because then you don't need to remember like what's the staging area and why do we need to do the git add for every file that we changed. And there is a cheat sheet which we already got posted in the comments. You see there is a lot of commands there. So some of the important ones we have not covered yet include git diff, that shows you the detailed changes that you made locally. Git log, that shows the history of all the changes in the repository in your current branch. And we have not talked about the pull, fetch, and push at all, which is a way to put your changes out to the world, to the repository. And I think that we will eventually talk about when we talk about GitHub. It's part of the core Git, but I don't want to overload you with new information, because essentially all I want you to be comfortable with is that workflow. Each of them is a set of commands. When you get the work done by others from GitHub, it actually has on the welcome page like how to do that. You make the changes, you stage them, commit, and repeat that process all over again. Essentially, wait, where's that picture? That one. That one. So this is the main visualization I want to leave you with after today's presentation, is that when you're working with Git, most of the operations are local to your computer, which is also crucial because you most of the time not in danger of breaking other people's work, because even if you delete somebody else's branch, you deleted your own version of it. That other person still has it. It's just all fine. But you have 3 different areas, which is your working repository, working directory, which is what you're working with. Staging is the area when you prepare the commits, and the repository when you committed them. And the repository is not the set in stone and unchangeable. Your local repository, you can still do anything with it before you push it forward. So for example, if you worked through the whole night and finished some work at 2 a.m., but you didn't want your manager to know that you really wrecked your lifestyle, you could change the time and say like, that all was done like 7 p.m., which is late, but not terribly late in the night, and push that as a set of changes. So all of those 3 areas are fully available for you for operations. But it's important to know that each of them has their own purpose, and that's your normal workflow. Change the files, add, commit. Change the files, add, commit. Eventually, you're all done with them to git push. That's all I wanted to present to you. We're quite a bit later than I expect us to finish, but we will later to start, so hopefully it's all fine. Now would be the good time for the questions, if you have any. Thank you. Well, and if you missed that presentation, I hope that will be available as a recording. And if anything, I did not present anything that's not available out there on the internet. There are multiple slides, multiple videos of people explaining how to work with Git, aimed at different levels. I tried to focus only on the bits that I feel crucial to begin working with Git, which is that screen that I'm still sharing. That those 3 areas, confusing at first. Nothing wrong with that one, to be confused by the like why instead of 1 set of files you now have 3 suddenly, and even more once you get into branches. But it's crucial to understand that Git has the memory of all the different branches, all of the different stages that the project has been through. And if you do through that process every time something works, as I do, then Git holds you back. Has you back. Wow, sorry. Anyway, so you can always go back to the good known state. And in HighTechU, you have mentors and stuff to help you navigate that world. Cool, and since it's the very first time I'm trying streaming anything on Twitch, I have no idea how the streamers deal with information when they done with the topic. I don't know, finish the demo. Cool. I think I'll just press the stop streaming button and hope you enjoyed it. Thank you.